Hello again. Today again we will talk about the joins, but this time we will touch more the performance aspect. For this performance aspect, we have created a little script. Our little script will create the big AMP and a big depth table. The big AMP and the big depth table are perfect replicas of AMP and depth table that we already know, but they will be filled with much more data. So let's execute the script. So it is done. We have 400,000 rows inside the big depth table and 1,500,000 rows inside the big AMP table. We want to test the execution plans. Let's go. First, our usual execution plan. We retrieve all data from both tables. And we have obtained what is called the hash join and the full scan of the two tables, since we have asked all of data from both tables. The second possibility will be, now if we narrow the range of data we are asking, what we obtain is a nested loop plan, and we have accessed the data passing by two index scans, one range scan and one unique scan. So it's time to see a little bit more about joins from the performance point of view. So we have basically three ways to join two tables in Oracle. We have a nested loop join, a hash join, and a merge join. So nested loop join looks something like this. If you are familiar with C or Java or C++ or such kind of this of programming, then you know what is it. This is a nested loop. So there is this loop that is executed, and it is nested inside the first loop. So for every execution of the first loop, there is a 1,000 execution of the second loop, and this is what is called a nested loop. So what is happening here, if we have a nested loop, so it will go to the big depth table and then go to the big AMP table, retrieve all rows, then again it will go back to the big depth table, retrieve the row, go again to the big AMP table, and this is what is called a nested loop. The second possibility is the hash join that we saw, and it's all about the hash map of the second table, and it will perform this. It will scan the first table and find a row in the second table with the hash key. And what is the hash key? It is the joining key. So let's see it. The hash key is the joining key. In our case, it is a depth no. So this key, the value of the depth no, will be used as a hash key. And what does it mean exactly? It means that the value of this key will be used to calculate the position of the row in the second table. We will see that more in details. This is just for starting and explaining the concept. And the third possibility is a merge join. So basically, this is the algorithm that will sort both tables, and then it will make a join on sorted data. We will see this more in detail. Don't let me forget. So what is happening when I put the outer join? Will it change something to the execution plan? Oh my god. Okay, let's see what's going on. We have a simple hash join outer. Since we have performed outer join, the same thing will happen with the nested loop. We will obtain the nested loop outer. We will see that more in details. Thank you for watching.